Now, responding to security threats, so that is called the attack mitigation, which is the process of preventing or responding to a breach in network security investigation. So as you're going to see, you can either prevent an attack from happening, or you can respond to an attack as it happened and as you have discovered that the attack has happened. And attack mitigation can be of two types. It can be what is called a proactive mitigation, which means that you have specific solutions which are implemented in the network in order to prevent attacks before they occur. That's going to be, for example, a firewall blocking access to a specific port. So if you know, for example, that a well-known vulnerability on Windows resides on the SMB protocol, which runs on TCP port 445, then as long as you block all access from the internet with your network on TCP port 445, then nobody's going to be able to make use of that vulnerability, because the service that it runs on top of it is being blocked. So that is a proactive attack mitigation, or a proactive measure. And they are called to be reactive, which means that those kind of tools respond to attacks either once the attack has occurred, or as it is occurring lively in the network. An example could be an intrusion prevention system which shuns an attacker running a port scan. So for example, so you have allowed specific access in your network from the internet, but somebody scans, we're going to speak in greater detail about scanning, somebody scans your network to identify which ports are opened, and as you have that IPS deployed in a network which is going to identify a port scanning happening, then that IPS is going to detect that attack. So basically it's reactive, because something is going to happen after the attack has been detected. So it's going to detect the attack and it's going to signal to a firewall, for example, to shun or block all traffic from that attacker which scans the network. So now, to implement attack mitigation, the first step of mitigation is to understand possible vulnerabilities and attacks, as I was saying before, which is pretty much the same thing as the most important step in network security design. So you gotta understand what are you exposed to, and out of those possible, let's say, attacks, which ones apply to your network, to your systems. And now different tools are available for mitigation depending on whether confidentiality, integrity, or availability is being attacked. But in general, which we're not going to have enough time to see this, especially live on the CLI, but even to speak about it in the CCNA class, is that in general, for the protection to be effective, you have to implement up-to-date security solutions adapted to current threat models. Like, for example, and we're going to speak about this probably tomorrow. So if the debate has, let's say you have done an assessment in your network and you want to buy a firewall to deploy the firewall in specific regions of the network. And then you end up with with the idea, what do I have to implement in there? Do I need a regular network firewall which does basic IP, layer 3 and layer 4 restriction? So it's like the IP tables of a Linux box. It allows back and forth traffic, but it can restrict it only based on the layer 3 header, like what is the source destination IP, or based on the layer 4 header, like if it's TCP or UDP, what are the port numbers, which ones are allowed back and forward. So you might need a regular firewall, or you might need what is called a next generation firewall, which, for example, if you allow access on port 80 from the network towards the internet, so you allow users access to port 80 on the internet, TCP port 80, which that's the HTTP port, then nowadays a regular firewall is not useful for that security policy. because nowadays the software tools, the hacking tools, the options have evolved in such a way that you can actually tunnel any kind of traffic you want on top of TCP port 80. So you need a next generation firewall deploy, not a regular firewall, because what you want to do is you want to actually perform application inspection of traffic over TCP port 80 to identify if that's real, valid, legitimate HTTP traffic, or is actually the user trying to send SSH traffic over HTTP, or is the user trying to send messenger traffic over HTTP, or is the user trying to send FTP traffic over HTTP? And that's called HTTP tunneling. So you can inject inside the HTTP packet whatever else you want. So you got to make sure that in general you need to put in the network solutions and mitigation technologies that are up to date with the current threat level, with the current threats. And the problem with this approach, which is why a lot of organizations are left behind, is that this constantly changes. The security field requirements, the attacks are evolving constantly, more and more rapidly, which means we need to bring in the network newer solutions or newer versions of an existing solution in order to be able to actually secure the network and the assets at the required level we have, agreed within the organization that it's an acceptable level of security. So you have to constantly evolve, adapt, which is not only time consuming, it's very expensive. And only organizations that actually have, are large organizations with huge money power, they can actually invest and adapt constantly to whatever shows up as an attack option. But one of the most, let's say, one of the other most important aspects, which is very often forgotten about within network designs, is that security solutions need to integrate and communicate into what is called a security architecture. What I mean by that is that upon attack detection upon a attack detection or an infected endpoint being detected, the security architecture needs to be able to alert appropriate people, appropriate personnel from the security department, and take action automatically. Like most of the organizations are lacking this vision, because this is a vision which is going to allow you that whatever you implement in the network as a security, as an attack mitigation tool, or as a security technology, not only in general, what organizations are doing are focusing on, we have to prevent this attack from happening against this specific asset. What is the best tool we can use? What is the best technology, which is also cost effective, to defend that asset or the network to achieve a security level of 80, for example, or of 75. That's the common approach, which is wrong, because the correct approach is that we have to look a bit further. So of course that what I said before, it's a correct assessment which should still be done to make sure that I implement the proper attack mitigation technology to defend a specific asset or network device. But I also have to select from the available options, because you're going to end up having multiple options as tools, or multiple vendors that offer the same technology. Like, let's say you're going to end up choosing a firewall as your technology to prevent against specific attacks. And then you have different types of firewalls, so which one do you choose? And then you have different vendors that for the same type of firewall, let's say we speak about application firewall, for the same type of firewall, they have different approaches, and their solution, their firewalls, is actually capable to integrate and communicate with other security solutions that you might have in the network. And that's actually the end goal. That's what you should be looking for as you bring security in the network, to build a security architecture. Like, for example, let's assume that, looking at this diagram in here, like let's assume this is the internet edge. So this side is the LAN side where users are residing, and on this side we have the internet. And let's assume that also this device in here, ACS1, it's actually Cisco's Identity Services Engine, which is a unified, converged, unified policy for network control access. So ICE allows network devices like switches, routers, VPN gateways, access points to allow and to authenticate users or devices accessing the network, and also to give them proper authorizations, like in which VLAN should that device belong to, and what kind of network access should that device be given, which is in terms of an access list. Which let's consider that ICE controls the network access of TestPCA, where Christian is being connected. So Christian is logged on TestPCA, and the network access has been enforced by ICE to allow IP traffic, so full network access to Christian. So currently Christian is given full network access. He has been authenticated and authorized for full network access. So this is the input. But let's assume that, for example, somebody from the internet, like we have in here an attacker. So an attacker from the internet somehow identified a vulnerability on Christian's system and has launched an attack which somehow was successful, and now Christian's PC is infected with malicious code, which allows the attacker to gain access in the network like a backdoor. But let's also assume, as you can see, that traffic flows through your firewall. So if your firewall, if that firewall, the ASA3, if this firewall ASA3 was actually implemented in there to defend against such kind of attacks, it means that the firewall has detected the attack. And now the firewall can block the attacker from gaining access to the network. So if the firewall has detected the attack, it means that if it's configured properly, it is able to block the attacker's access in the network. But the problem still remains that now, because of the attack was successful, the endpoint was infected, which means that now the attacker, it's like he has access to the inside of the network through the malicious code which was installed on Christian's PC. So it's like the attacker is actually on the console of that PC, and he can do whatever he wants at this point. So then why do you need that security architecture? Because, so let me lay this to begin with. So at this point, when Christian's endpoint got infected, the firewall has detected that and blocked the attacker. But now, because of that malicious code which got installed on Christian's endpoint, is like the attacker is in the inside of the network. Actually, what you would want your architecture to do is you would want ASA3, the firewall, so the device that detected the attack, the firewall, the attack detection device, you would want ASA3 to signal to ICE that PCA, which belongs to Christian, is infected. Why would you want this? Because ICE was the solution that allowed Christian full network access to begin with. So if ICE has authorized Christian to get full network access previously, now if the firewall signals to ICE, hey, this PC got infected, take action, then ICE can be pre-configured to take action. That's going to happen automatically. So what ICE can do is now ICE can signal to the switch, the PCA of Christian is connected to a switch in here, to switch 1, let's say. So now ICE can actually signal to switch 1 to change the authorization of Christian's PC in order to go from permit IPNNA, which was full network access, to, for example, permit only ICMP traffic, or maybe permit only RDP traffic, so that that device can be remotely controlled, so that somebody from the security department can actually connect to that computer and see what is the infection level, and then try to clean up the infected endpoint. So this is what a security architecture means, is that different security technologies involved and implemented in the network can actually communicate one with each other in order to either detect the attack and stop it, or detect it, stop it, and or detect it, and if it was detected after it has been successful, then quarantine or block network access automatically of infected endpoints, so that no other endpoints are likely to be infected, or, for example, to make sure that the infected endpoint cannot be used to further leak data from other systems in the network. So security architecture is a concept of vision that allows you, that should basically allows for the network security devices or technologies to communicate one with each other in order to better secure the network. And in general, it happens in this way. Some technologies are going to detect an attack, some of them are going to prevent the attacks, but the technologies that detect the attack are not necessarily the same ones which allow network access to begin with, which is this use case, where the ASA firewall has detected the attack, but then network access for the user was given by Cisco's Identity Services Engine. So then you would want the ASA firewall to tell to ICE, dear ICE, this PC is infected, take action. Why? Because the firewall cannot control the switches configuration or the access points configuration which allowed the user access the network to begin with. ICE did that. So whenever the tool that the technology that detects an attack and the technology that can block that attack are not one and the same, it means you need some kind of communication back and forth between those systems to actually take action automatically and safeguard the network. Because if a couple of years ago, if an attack being successful for 6 hours, or if an infected endpoint was left in the network for 6 hours without his access being blocked in the network, if that was good enough a couple of years ago, then nowadays it's no longer the case. Because nowadays the attackers know that once they got on the inside of the network, so somehow they got access on the inside of the network, they have limited time till they're going to be discovered and their access is going to be blocked. So that's why you need some kind of automation. So you'd want ICE to then block, for example, all network access for that PC, and then it's going to also generate an alert to the security team, and the security team at that point can be kind of like relaxed because the endpoint was quarantined, has been blocked for any kind of network access, so they can actually go physically at that endpoint, pull it up from the network and put that endpoint in a specific testing area environment, or they can clean it up or follow up the cleaning procedure of that organization, whatever that is. For example, some organizations have a cleaning procedure to actually remove viruses and worms from infected endpoints. Some organizations have another kind of policy which states if an endpoint was infected, then we don't clean up the mess, we just reinstall from scratch the operating system and all of the applications from an image. So of course each let's say each option has its own advantages and disadvantages, but in the end, in both cases that was possible because the infected endpoint was instantly being blocked access to the network automatically by the security architecture.